Hello everyone, and welcome today to my Pure Math YouTube video. Today I'll be going over the form of a cos theta plus b sin theta. And this is in trigonometry, so we're going to start. Now, this sounds very arbitrary, but before we even get into that, I'm going to go through some foundational things that we need to know before getting into that. So, what are these foundational things? Well, the graph of sin x and the graph of cos x. So, I'm going to draw just a graph right here, and I'll show you what I mean by that. And I'll tell you what to pay attention to, so don't worry. So if you just looked up the graph, you'd also find this. So the graph goes up by from 90 to 180 to 270 to 360. And that's one full cycle. And sine starts at 0. It has its maximum at 90, comes back down to 0 at 180, and it comes back here at 360. Now this drawing is not done to scale, as you can obviously see, but what I want us to pay attention to is what is the maximum value of sine, because this is where y is equal to sine x. Well, what's the maximum value of sine? So it's kind of hard to see, but if you look at 1, which if it was drawn properly you would see, the maximum value is at 1, and the minimum value is at negative 1, or, well, it should be at negative 1, but yeah, it's kind of hard to draw curves. But yeah, so for sine, max is equal to 1, and the minimum value is equal to minus 1. So we'll find the maximum value of sine being 1 and the minimum being minus 1. Now what about cosine? So let's quickly draw the graph of cosine. Again, this won't be done to scale because I don't know how to do that. And similarly for cosine, we have 90, 180, 270, oops, it's a little bit too short, and we'll just say 360 here. Now this could also be in radians, but for the sake of teaching purposes, it's completely fine. And this is of course the graph, well, will be the graph of y equals cos x, but before that, what we do is cos starts at its maximum. So if you realize for sine starts at 0, right? Whereas cos, instead of 0, because if you look right here, this is where the sine graph starts. It gets to its maximum at 1, goes down, and gets its minimum at negative 1, and goes back to 360, and that's one full cycle. But for cosine actually starts at 1, it starts at its maximum, and then goes down. Okay? I'm trying to see if I can make like a curve, kind of, like you kind of get the point, and then it goes up. Okay, I'll just have to try, because yeah, this is not working out. So it goes down like this, goes up like this, and yeah, so for cosine now, the maximum value should be 1, and the minimum value is also negative 1. Now this is not drawn to scale, but that's kind of what it should be. And yeah, so that's what you need to just keep into consideration. So for y equals cos x, max is equal to 1, min is equal to negative 1. So they had the same maximum and minimum, so that's just something that we need to know. Okay, now let's actually get into the form of a cos theta plus b sin theta. Okay, so let's say we have a question, and the question asks us to solve, or well, not solve, but express 2 cos theta plus sin theta in the form of r cos theta, or well, r cos of theta minus alpha. Now, you're probably like wondering what's going on. Where did theta come from? Where did theta minus alpha come from? Where did r come from? We will solve all these things right now. But what you should do instantly, when you see something like this, now this can be expanded. So if you remember from the last video that I posted, r cos theta, well, cos of a minus b is equal to cos a, cos b, and remember the sign should be opposite, so it's plus sine a, sine b. Okay, and this was taught in the last video, so if you don't understand that, you should go back, because I taught the angle sums and double angle formulas. So that's just something to keep in mind. So okay, we know it can expand like that. So what would this be in terms of r cos theta minus alpha. So we'd have r, we could just say r is being multiplied outside, so we have r times, when we expand this, what do we get? So we get cos theta, cos alpha, plus, because it has to be opposite from what's inside the brackets, plus sine alpha, sine theta, sorry, sine alpha. Okay, and now we can actually expand, we can distribute this r, so r cos theta, cos alpha, plus sine theta, plus r sine theta, sine alpha. I'm so sorry, up here should be alpha, slight mistake. And yeah, so don't forget to distribute the r to both terms, because that's what you have to do, okay? And yeah, great, so now we have this already, so that's good. What do we want to do now? So what we can do is we can equate these two terms, because if 2 cos theta plus sine theta can be put in another form, that means it should just be the same thing, right? So what we can say is 2 cos theta, taking the 2 cos theta from the question, which asked right here, so 2 cos theta plus sine theta should be equal to r cos theta cos alpha plus r sine theta sine alpha. Now, this is in the same way as saying, for example, that 2 to the power of 2 is the same thing as 4. Now, this is just two different forms of writing 4, but they're equal. So, in the same way, if something's expressed in another form, we can just say that it's equal. And that's what we're doing right now. So we have this, and well, what can we do now? Well, here's where the only part that might not be extremely intuitive comes in. What we have to do is just equate the coefficients. So here we have 2 cos theta. So what has a coefficient of cos theta? Well, if you look over here, you'd realize that cos alpha has a coefficient of cos theta. Now, if you remember what a coefficient is, it's a term before this. So this is the coefficient of cos alpha. So what we can do is equate coefficients, and you'd learn this from polynomials. I've also done a video on polynomials if you'd like to learn how to do that. I'll be redoing every video on my channel though, because I'd want to up the quality. So this is the redo of the video. So we can equate these coefficients. So we'll have 2 cos theta is equal to r cos theta cos alpha. Now we can just cancel out these cos thetas, which would leave us 2 is equal to r cos alpha. And we can label this as equation 1. Okay. Now what about sine? So we have plus sine theta. Now what has a coefficient of sine theta? Well, if you look on this next term, sine alpha has sine theta before it. So what we can do is we can equate it. So we can have 1 sine theta is equal to r sine theta sine alpha. Now I put 1 here because when there's nothing there, we can assume that the coefficient is 1. So in this case, we can cancel out the sine theta, so we'll have 1 is equal to r sine alpha. And this is the second equation. Now what we want to do always is we want to find a way right now that we can actually get alpha. Now how could we do this? We don't know what r is, right? So we need to find a way to cancel r out. And at the same time, we need to find a way to get a value. So if we're going to be solving for this, what could we do? Well, what we're going to do is we're going to divide equation 2 by equation 1. Now, why are we going to do this? So if you look keenly, if you remember that tan theta is equal to sine theta over cos theta, that means that we could find, we could do this actually, yeah. So what we're going to do is we're going to find whichever equation has sine theta, which in this case is this one, and divide it by the equation that has cos theta. So we're going to divide equation 2 by equation 1. So in doing this, equation 2 we know is 1 is equal to r sine alpha over, and equation 1 is just up here, equation 1 is 2 is equal to r cos alpha. So equation 1 is equal to 2 is equal to r cos alpha. Now, if we divide these two things, the r's cancel out, and sine alpha over cos alpha is just going to be equal to tan alpha. And 1 over 2 is just a half. So I'm just going to rewrite this again. So we have tan of alpha is equal to half. Now this way, we can say alpha is equal to tan inverse of a half. And let me plug this into my calculator. Shift tan of a half. And we will get alpha is equal to 26.56 degrees. Okay, so now we have alpha, and that's great, right? Oh, I'm hitting into my disk. So it's great, we have alpha, so that's good. So what can we do now? We can rewrite the equation with alpha in it. But the problem is that we actually want to find r as well. So when we put it in the form of r cos alpha, I'm trying to find a way to put it into this form over here, we want to find r as well. So how could we find r? Now, this is going to take a little bit of big brain, okay? So I'm going to rewrite our two equations that we had before, because we now know alpha is equal to 26.56, and that's great. But I'm going to rewrite the equations we had before, which is 2 is equal to r cos alpha, and 1 is equal to r sine alpha. So we want a way that we can find the value of r. Okay? Now, here's what you need to do. So if you remember from the fundamental identity that cos squared theta plus sine squared theta is equal to 1, well, we can actually use this to solve this equation. So what we're going to do is we're going to square both equations. So in squaring equation 1, we'll have 4 is equal to r squared cos squared alpha. And equation 2 is going to be 1, because 1 times 1 is 1, 1 squared is just 1, is equal to r squared sine squared alpha. Now if you see where I'm going here, so what we could do actually is we could add these two equations. So before we divided them to find alpha, but what if we added them now? Well, if we added them, we'd be able to have something that deals with cos squared theta plus sine squared theta, right? So what we're going to have is 4 plus 1 is equal to r squared cos squared alpha plus r squared sine squared alpha. My alpha sign is like bad. Okay, now what can we do here? 4 plus 1 is just 5 is equal, and we can actually factor out the r squared. So r squared times cos squared alpha plus sine squared alpha. And we know that from this identity that cos squared alpha plus sine squared alpha is equal to 1. So we have 5 is equal to r squared times 1. This way we know r squared equals 5 and r equals root 5. Great. So now we know the value for r, and we also know the value for alpha. So we can rewrite the equation now. So we wanted to rewrite 2 cos theta plus sine theta. So I'll just rewrite that down here. So we'll have 2 cos theta plus sine theta should be equal to r cos theta minus alpha. Now plugging in these values, we know it's going to be equal to r, which is root 5, times cos of theta minus alpha, which we found to be 26.56. And there we go, we have just expressed it in this form. And that's great. Now, what we're going to want to do now is we're going to want to find out how could we find the maximum value of this. So if they asked us to find the maximum value of 2 cos theta plus sine theta, well, how could we do that? Well, remember what I said before, that the maximum value of cos theta is going to be equal to positive 1. So we know cos theta at max value is equal to 1. This way we can multiply root 5 by cos theta, well in this case cos theta minus 26.56. But this inside here should be equal to 1 at its max. Because remember, cos theta, no matter what, the inside of cos is at its max, at 1. So that would mean that what's inside here would cause cos to go to 1, okay? And if we're multiplying root 5 by cos theta, or we want to find the max, well the max is just root 5 times 1 equals root 5. So at any given time, the maximum value of this is going to be equal to r. So when you find r, you're not just finding r, you're finding the maximum value that will happen. Now, what about the minimum value? So we know that cos theta is at a minimum value at -1. So this way we know that cos of theta minus 26.56 should be equal to -1 at its minimum value. Which means that if this is equal to -1, we can replace cos theta minus 26.56 with -1. And remember, this is being multiplied by root 5 times -1 is going to be equal to -root 5. And that's how we would find the minimum value. Okay, great. Now, let's move on to another example. This one's going to be slightly more challenging, but, that's good. So let's move on. So let's say they want us to write the function f of x is equal to 7 cos x minus 24 sin x in the form of r cos x plus alpha. Okay, so what do we want to do? So we want to just write it in the form. So we know if this can be written in another form, then it should be equal to this other form, right? So to do that, we're just going to rewrite this as 7 cos x minus 24 sin x should be equal to the other form, which is going to be r cos x plus alpha. So when we see something like this, we know we can expand it. So this is going to be equal to r times cos x cos alpha minus, remember it has to be the opposite of the sign inside the brackets, minus sin x sin alpha. And expanding this, we'll get r cos x cos alpha minus r sin x sin alpha. And this should be equal to 7 cos x minus 24 sin x. So I haven't done anything weird yet. All I've done is I've just expanded using something that we learned, the expansion of the sum thing of angle sums that I taught in the last video. So what do we want to do now? Well, we want to solve for r, so we're going to just try to solve for r first, okay? So to solve for r, well, how do we do that again? Do you remember? We equate coefficients. So what has a coefficient of cos x? Well, cos alpha does. So what we'll do is we'll equate it. So we'll have 7 cos x is equal to r cos x cos alpha. And what this is coming from is actually if two, well, I don't know if it's polynomials, but if two things are equal, that means that their coefficients have to be equal. Again, this was taught in, I believe it's chapter 4 of some textbooks. So, and it's also probably my 4th video, or 3rd video actually. So you should, or actually it might just be my 2nd, so you should just check that out if you don't understand how to do this. Now, similarly, what has a coefficient of sin x? Well, in this case, sin alpha has a coefficient of sin x. So we have -24 sin x is equal to -r sin x sin alpha. So we can simplify these by cancelling out the cos in the first one. So we'll have 7 is equal to r cos alpha, and in the second one we have we cancel out the signs. We have -24 is equal to -r sin alpha. Okay, and we can just say that we can just kind of cancel out the negatives because both of them are negative and just say it's positive, okay? Because if you multiply it by -1, you'll just get this, and it's completely fine. So what do we want to do now? So this is up here is equation 1, and this is equation 2. And what do we want to do? Well, we want to find a way to get tan of alpha. So how do we do this? Well, we have 24 is equal to r sine alpha, and if we want to get tan, since we know that tan theta is equal to sine over cos, then if we have r sine alpha, we just need to divide it by cos sine alpha. So we'll divide equation 2 by equation 1. So it will be over 7 is equal to r cos alpha. Now when dividing this, the r's cancel out, and we have 24 over 7 is equal to tan alpha. This way we can solve for alpha, alpha being tan inverse of 24 over 7. Okay, so if you take 24 tan inverse shift tan of 24 divided by 7, you will get alpha is equal to 73.7 degrees. Now that's great, so we have alpha. Now what else do we need to find? Well, we need to find r. So to find r, how do we do that again? So I'm going to rewrite the equations just because I want it to be as clear as possible. 7 equals r cos alpha. So we have 7 is equal to r cos alpha, and 24 is equal to r sine alpha. And we want a way to get cos squared theta plus sine squared theta, because we know that's equal to 1, and anything multiplied by 1 is itself. So to do that, we're going to square both sides. So we're going to square here, and we're also going to square here. Now, the first equation squared is just going to be 49 is equal to r squared cos squared alpha. The second one squared, well, unfortunately for me, I don't know 24 squared on my head, but it's going to be equal to 576 is equal to r squared sine squared alpha. Okay, and what can we do now? Well, we can just add these things. So we can say 49 plus 576 is equal to r squared cos squared alpha plus r squared sine squared alpha. And we can factor out the r squared on the right hand side, but before that we'll add 49 plus 576, which gives us 625, is equal to r squared, and we just factored it out, cos squared alpha plus sine squared alpha. So this chapter really does a lot about polynomials, factoring, and stuff. So if you're not strong on those as foundation, I'd recommend brushing up on that, and it will help you a lot in these kind of questions. So let's go. So we know that cos squared theta plus sine squared theta is equal to 1. So it's going to be equal to r squared times 1, which is just r squared, and 625 will equal to that. So if r squared equals 625, that means that r is equal to the square root of 625. And if you put in your calculators, root 625 is just going to be equal to 25. So r is equal to 25. Okay. And that's great. So remember the first equation that they gave us? They gave us that 7 cos x minus 24 sin x should be equal to something else. So I'm just going to rewrite that again. So we'll rewrite it as 7 cos x minus, wait, I've actually forgot it. So 7 cos x minus 24 sin x is equal to r cos x plus alpha. And now we know that 7 cos x minus 24 sin x is equal to, well, we know r is 25 times cos of x plus alpha, which alpha was found up here to be 73.7. So cos x plus 73.7. And that's great. So we just found it in that form. Now, what if we wanted to find, what if the question asks us with section B? So the question now says B, hence, solve the equation 7 cos x minus 24 sin x equals 4. So now this is a little bit different. They're not just asking us to just put it in that form, they're asking us to solve it. So we know that this is equivalent to the form r cos x plus alpha. So in place of this, we could actually use r cos x plus alpha, where alpha being 73.7. So because these two things are equal, remember, we've been saying they've been equal for the whole time, well, instead of writing 7 cos x minus 24 sin x equals 4, we'll have 25 cos of x plus alpha is equal to 4. Okay, now solving for cos of x plus alpha, we just have to divide both sides by 25. So cos, these things cancel out, cos of x plus alpha is equal to 4 over 25. That means x plus alpha is equal to cos inverse of 4 over 25. And well, if you put this into your calculator, shift cos of 4 over 25, you get that x plus alpha is equal to 80.8. Okay, now we remember that alpha, because remember we found alpha previously, and found it to be 73.7, so x plus 73.7 is equal to 80.8. Okay, now solving x plus alpha is equal to 80.8 by taking the cos inverse of 4 over 25. And now we just substituted in the value of alpha that we found previously, which was 73.7. Now to solve for x, we have x is equal to 80.8, oops, minus 73.7. So you put that into your calculator, or you could do it mentally if you're good like that. X is equal to 6.3. Okay, and remember that whenever we're doing something like this, we always have to do our little cast diagram. So C, A, S, T, in which quadrant is cosine positive? Well, cosine is positive here and here. Draw your angles, 0, 360, 90, 180, and 270. So right here is going to be equal to 6.3, and down here is going to be equal to 350. Well, you can just actually, I'm not going to trust myself. 360 minus 6.3 gives you 353.7. So S is equal to 6.3 or 353.7. And that's how we would solve the equation. We would just use what we were given because they told us that it could be expressed in the form. Well, we knew it could be expressed in the form since we expressed it in that form. And then we just replace this with what we had expressed in the r sine theta, our a cos theta plus our a cos theta plus b sine theta form. And then we solved. And it was pretty nice and easy, so hopefully that was something you can understand. And now the last part of the question asks us to find hence, well, since 7 cos x minus 24 sine x equals 25 cos of x plus alpha, what is the maximum value? So find the maximum value. Now, if you wanted to find the maximum value, remember that cos has a maximum at 1. So therefore, this is the same thing, this thing up here, 25 times cos x plus alpha is the same thing as saying 25 times cos of x plus alpha, which has a maximum value at 1. So that means we can replace this whole cos of x plus alpha with 1. So instead we'll have 25 times 1, which is equal to 25. Therefore, the max is at 25. Okay, great. So what are we going to be doing now? Well, now we're actually just going to be doing some past paper questions because it's always good to know if you really understand something. And yeah, we'll be starting with 2016. So let's look at this. Express the function f of theta is equal to sine theta plus cos theta in the form r sine theta plus alpha. So let's do it now. So I'm just going to rewrite the question first. F of theta is equal to sine theta plus cos theta in the form, so I want to express it in the form r cos theta, oh sorry, r sine theta, theta plus alpha. Okay, so this is pretty standard procedure by now. You see something that can expand, you expand it. So it's going to be equal to r times sine theta cos alpha plus cos theta sine alpha. Now, the reason why this is different from the last ones is because this time they use sine instead of cos. Don't let that trick you. Don't get into the groove of only thinking about one. Try to do it for all of them. So now, if we expand and distribute the r, it's going to be equal to r sine theta cos alpha plus r cos theta sine alpha. So sine theta plus cos theta should be equal to that. So now we can compare coefficients because this is equal. So sine theta, what has a coefficient of sine theta? Well, if you look for a coefficient of sine theta, you'll see here that cos alpha has a coefficient of sine theta. So we can say sine theta is equal to r sine theta cos alpha. And also for another equation, what has a coefficient of cos theta? Well, if you look over here, sine alpha, because sine alpha is right here, was before sine alpha cos theta, that means it has a coefficient of cos theta. So that means we can say cos theta is equal to r cos alpha, is r cos theta, sorry, times sine alpha. So now for the first equation, we can cancel out the signs, and since there's no coefficient that they told us, we can say it's equal to 1 is equal to r cos alpha. And for the second one, we can cancel out, and again there's no coefficient, so 1 is equal to r sine alpha. And this is equation 2, and this is equation 1. Remember, we want to get the r's cancelled out and we want to have tan in the mix. How can we do that? Well, we know that tan is equal to sine theta over cos theta. So that way we can say divide equation 2 by equation 1. Now to do this, we can have 1 equals r sine alpha, and it will be divided by 1 is equal to r cos alpha. This way these two cancel out, and 1 over 1 is just 1 is equal to tan alpha. Now solving for alpha, we get alpha is equal to tan inverse of 1. Now if you were to put that into your calculator, shift tan of 1, you'd get alpha is equal to 45 degrees. I know 45 could also be written as what's that? That's pi over 4. So it's equal to pi over 4 as well. So whichever one you want to work with. I'm just working with degrees because it's a lot more intuitive, and if you aren't very familiar with radians, I don't want to overcomplicate it. When you're practicing, you can put it in radians, and when you're in the exam, that's fine. But for now, I just want it to be as simple to understand, and once you understand it, you can always just add some extra steps. Great. So what do we want to do now? So again, I'm going to rewrite first and second equation, which is 1 is equal to r cos alpha, and 1 is equal to r sine alpha. I'm going to square both sides of both equations. I'd get 1 is equal to r squared cos squared alpha, because 1 times 1 is 1, and 1 is equal to r squared sine squared alpha. Now if I add equation 1 to equation 2, we'll get 1 plus 1 is equal to r squared cos squared alpha plus r squared sine squared alpha. And now we get 2 is equal to r squared, we can factor it out, cos squared alpha plus sine squared alpha. And we know that cos squared alpha plus sine squared alpha is just equal to 1. So r squared times 1 is equal to 2. Therefore, r squared equals 2, which means that r is equal to root 2. Great. Now, if you realize, we found both alpha and we have also found r. So we can actually come back up here and we can rewrite this whole thing. So we can say it's equal to f of theta is equal to sine theta plus cos theta is equal to r sine theta plus alpha. Now, we just found r and we found alpha, so we can actually do these. So we can say sine theta plus cos theta is equal to r, which we found down here, we found r to be root 2. So we can say it's equal to root 2 times sine of theta plus alpha, which alpha's value was found to be 45 degrees or pi over 4. So theta plus 45. And yeah, so that's actually what the question had asked us, and that's 5 marks right there. They just wanted you to express it in that form, so just knowing how to express things in this form will get you marks on a past paper. Now, let's move on to the next set of, well, next question, which is 5 marks as well. So if you can do both of these, that's 10 marks. And that's very good, because each section, each module is 50 marks, which means that you've already gotten 1/5 of the marks on the paper, because the pure math paper 2 has 150 marks. So keep that in mind. So hence find the maximum value of f and the smallest non-negative value of theta at which it occurs. So going back to what we know, if you remember, we'll just rewrite it first. We'll rewrite what we have. So we said they told us that so we know that we found r to be root 2 and we found alpha to be 45 degrees. So the max value of root 2 times sine of theta plus 45 is equal to what? So you know that sine is max at 1. Therefore, this would have to be at 1 for it to give us our maximum value. And if that's equal to 1, then the maximum value is equal to root 2 times 1. Therefore, the maximum value is equal to root 2. But they didn't just ask us for the maximum value, it's 5 marks, right? They asked us for the maximum value of f and the smallest non-negative value of theta at which it occurs. So let's work that out. So we know the maximum value is root 2. So we can say root 2 sine of theta plus 45 is equal to what's the maximum value? Maximum value is root 2. So if we divide both sides by root 2, we get sine of theta plus 45 is equal to 1. And if you take sine inverse of 1, it's going to be equal to theta plus 45. And put that into your calculator, shift sine of 1, you're going to get theta plus 45 is equal to 90. Therefore, theta is going to be equal to 90 minus 45. Theta is going to be equal to 45. And this is also just the same thing as pi over 4. And that's exactly how that question is worked. So again, this is just 10 marks, 10 free marks that once you know how to do something, you'll be making a lot of progress on that paper. And that's 1/5 of the paper completed, just like that. Well, of that module completed. So that's good stuff. Let's move on to our next question. So this next question seems pretty easy, doesn't it? It just asks us to express 4 sine theta plus 3 cos theta in the form r sine theta plus alpha. So let's do that. Let's first rewrite the equation so that we can work at our own pace. 4 sine theta plus 3 cos theta in the equals r sine theta plus alpha. Okay, so what do we do now? Immediately, you should always immediately just expand these now. It should start to become, my words right now, it should start to become intuitive now. So r times sine theta cos alpha plus cos theta sine alpha. Now distributing the r, we have is equal to r sine theta cos alpha plus r cos theta sine alpha. So we can say that 4 sine theta plus 3 cos theta is equal to that. Now, what has a coefficient of sine theta? We look for it over here, and well, if you look over here, r cos alpha has a coefficient of sine theta. So we can equate coefficients. So 4 sine theta is equal to r sine theta cos alpha. Cancel these out. We get 4 is equal to r cos alpha. Okay, great, and that's going to be our equation 1. Now, what has a coefficient of cos theta? So if you look over here, cos theta is before sine alpha, and that means that sine alpha has a coefficient of cos theta. So we can equate these two. So we can say 3 cos theta is equal to r cos theta sine alpha. And if we just remove the cos, 3 equals r sine alpha. And this is equation 2. And remember, we always want to find a way to get tan. And we know that tan is equal to sine theta over cos theta. So this way, if we divide equation 2 by equation 1, we'll get r sine theta, r sine alpha equals 3 divided by r cos alpha equals 4. The r's will cancel out when they're divided, and we'll get tan alpha is equal to 3 over 4. This way, alpha is equal to tan inverse of 3 over 4. So if you put this into your calculator, 3 over 4, you get alpha is equal to 36.86. Okay, nice. Now, what do we want to do now? Well, we want to find r. So how do we find r? So we have, I'll just rewrite the equations in a different color. So we have r sine alpha equals 3 and r cos alpha equals 4. You should be screaming at me, telling me what to do by now at the screen, because it should become that intuitive already. And so what will this become? Well, if we square both sides, sorry, this should not, this is both sides, we get r squared sine squared alpha equals 9, and we get r squared cos squared alpha equals 16. Now, if we add these two together, so if we add them, we get, it's going to be equal to r squared sine squared alpha equals 9, sorry, sine squared alpha plus r squared cos squared alpha equals 9 plus 16. We can factor out r squared, we get r squared times sine squared alpha plus cos squared alpha is equal to 25, and we know this is just equal to 1, so we get r squared times 1 is equal to 25. That means r squared equals 25, and that means that r is equal to root of 25, which means that r is equal to 5. So to rewrite the whole equation now, they ask us to rewrite it expressed in that form. So we can say 4 sine theta plus 3 cos theta equals r sine theta plus alpha. And we just found r sine theta plus alpha, so it's going to be equal to r, which we just want to find it to be 5, times sine of theta plus alpha, which we had previously found to be 36.86. So we can just rewrite this again. So 4 sine theta plus 3 cos theta equals 5 sine theta plus 36.86. And that's all I have for this video today. It's a very simple topic. Hopefully you're understanding it intuitively. And if you are, then that's good. I have a whole playlist on Pure Math Unit 1. And if that interests you to just completely finish the syllabus, then that's good. You can just binge all these videos. Probably don't wait until the last minute. And always practice, because at the end of the day, you could watch all these videos, but if you don't practice, you won't be able to build up that muscle memory. So with that said, that's all I have for this video today. Hopefully it was helpful to you, and yeah, goodbye.